Hi, welcome back, everyone. Let's go through chapter 12 for physics and math. I am actually starting the physics chapters based on a reverse chronological order, so let's start here. So, the chapter 12 is about database and statistical reasoning. I believe this is important for all science sections on the MCAT, as this is more of an analytical reasoning skill. So we have the measures of central tendency. They provide a single value representation for the middle of the data set. We have the mean, which is basically the average. We have the median, that is the value that lies in the middle of the data set. It tends to be least susceptible to outliers, but may not be useful for data sets with large ranges because you won't get the mean, but you would get the median, which is the only value that is right in the middle of the data set. Then we have the mode, where the data point is the data point that appears most often. And here we have the representation for them. So for a right skewed, this is actually called a left skewed, negative skewedness, and the skew is on the left, and the mean is the average for all the data set. Then we have the median, and the mode is the data point that appears most often. So we are having this here that is happening more often, and this is a right skewed, positive skewed representation. Now we have distribution. So normal distribution is symmetrical, and the mean, median, and mode are equal. So where you get a different mean, median, and mode is in right skewed or left skewed distributions. Now standard distributions are a normal distribution with a mean of 0 and a standard deviation of 1. It is used for most calculations. So here, I don't know if you can see the 1 sigma and the negative 1 sigma. These are the standard deviations. So one standard deviation gives you 68.2%. After only 2 standard deviations, you should get a 95%. And after 3 standard deviations, you get a 99+% distribution, representation of the data set, right? So in standard distribution again, it is a normal distribution, and the mean is 0 and it has 1 standard deviation. Now skewed distributions have differences in their means, medians, and mode. Skewed direction is the direction of the tail. So this is why it's positive, because the tail is on the positive end. Now for bimodal distribution, it has multiple peaks, although not necessarily in multiple modes. So the modes are not the same as peaks here, because in the bimodal distribution, you might have one peak that is the representative of the most often happened data. So with the most occurrences, that is the modes. But with the peaks being multiple. So we can dig into bimodal distribution later. For the measures of distribution, we have a range, which is the difference between largest and smallest value. Nice. We have interquartile range, which is the difference between the value of the third quartile and the first quartile. It can be used to determine outliers. So the difference between the third quartile and the first quartile, and we have 4 quartiles, right? Now this we call the interquartile range. We have standard deviation, which is a measurement of variability about the mean. It can be used to determine outliers. So we can use the standard deviation to determine outliers. And for outliers in general, any value that lies more than 3 standard deviations from the mean is an outlier. Now for probability, we have independent events. The probability of independent events does not change based on the outcomes of other events. We have dependent events. The probability of a dependent event changes depending on the outcomes of other events. Terminology, mutually exclusive. It cannot occur simultaneously. When a set of outcomes is exhaustive, there are no other possible outcomes. So exhaustive means no other possible outcomes. Statistical testing, we have hypothesis tests. So by the way, for dependent variables and independent variables, we usually or always have these graphs on the MCAT where you have an x-axis and a y-axis. And is it the x-axis that's dependent on the y-axis? So let's figure out. Usually you're measuring, for example, time on the x-axis. So it's moving forward, okay? And these variables on the y-axis, you want to see how much they change based on this right here. So probably, I'm assuming, most often, or maybe always, your x-axis is the independent variable because the time moves forward, and the outcome of the y-axis depends on that, right? So that's why your y-axis would be the dependent variable. Now for hypothesis tests, we use a known distribution to determine whether the null hypothesis can be rejected. So you use known distribution to determine whether null hypothesis can be rejected. The p-value is whether or not a finding is statistically significant, is determined by the comparison of a p-value to the selected significance level, alpha. A significance level of 0.05 is commonly used. This shows that the outcome that you got from the research, for example, is 95% reliable. That's what it means, I believe. So let's see it here. We have confidence intervals, which are a range of values about a sample mean that are used to estimate the population mean. A wider interval is associated with a higher confidence level. 95% is common. So that wider interval will tell you that the 95% of the data, the results that you got, is reliable based on the whole population, for example. Hypothesis testing chart with type 1 and type 2 errors. So these are the conclusions that you draw, and these are the true states of nature. So we, for example, predict that the passenger is safe. And based on the truth of it, passenger is innocent, meaning he is not armed. So we had a good conclusion, or we call it a hit in psychology. So you hit the target, you didn't miss it. Now, the other green is that you say the passenger is dangerous, so you do predict a negative, and the passenger is not innocent and he is armed, so you guessed right still. And that means, but on the negative, that the fact that the passenger is harmful. This would also be a hit, but there might be another term for it in psychology, so we can come back to it. This is let's just take a look at it quickly. Should be like the risk associated decision making. Not here. Not in memory. Not in cognition. Not in stress and emotion. Not in here. These are disorders. These are attitudes and behaviors. Might be here in social thinking. Yeah, no, so like you can come back to it later. We must have them on the Anki Dex. Now we have type 1 and type 2 error. So type 1 is when you predict that the passenger was dangerous, but they're not. You deny boarding to a safe passenger. It is not ideal, but preferable to allowing a dangerous passenger on board. That's why type 2 error is more dangerous, because you allow a dangerous passenger on board. It's really bad. So type 1 error is preferred over type 2 error. That's interesting. Charts, graphs, and tables. Pie and bar charts are used to compare categorical data. So for categorical data, we have pie and bar charts. For histograms and box plots, we use them to compare numerical data. So histograms and box plots. For linear, semilog, and log-log plots, it can be distinguished by the axes. And the slope is the rise over the run. So if you're rising faster, it means that your slope is greater, can be a representation of acceleration. And when you are in the run is when you're moving forward. So the more you rise over your compared to your running, it means that your slope is greater. So the slope here is 0. The slope here is 1 or more. And the slope here is -1 because it's falling. And the exponential relationship is represented like this, the logarithmic relationship. This reminds us of the Michaelis-Menten curve. And this is a quadratic relationship. It's the opposite of the normal distribution, kind of, or curvilinear relationship. Quadratic, U-shaped, curvilinear. Okay, not bad. So let's let's actually put chapter. Please don't read my personal journal. I mean, you're gonna probably read it. And it's super obvious now. But who cares? Let me actually read it. It might be motivational. I do actually see myself in a higher being and status when I'm putting in the work. Why do I not feel like doing this studying? This was like when I was feeling overwhelmed by the material last night. It is because I feel overwhelmed by it and I am behind. That was like one of my rationalizations. That I have so many other things to do and I don't feel like I'm in control. Could be. Is it that I'm depressed because I can't do anything about it? Because if I was stressed out, it meant that there's something I can control, but this is not the case I am feeling. This was actually kind of based on what Jeff Bezos was saying, as I saw in one of his interviews from back in the 90s, as he was saying that if you are stressed, you can't, it is a sign that you have some sort of control on the situation, but you're not doing it. That's why you're stressed. I will win the battle with myself. I know this is the hardest battle. Some like you versus you motivational talk. Okay. Since we have to do a psychology sociology chapter 2, I would actually like to use go to the chapter that has the bias stuff in it. So in order to do that, I will just go back to chapter 1, as I believe that's where it should be. Okay, it's not, because chapter 1 is based on biology stuff, so it should be chapter 3, I believe, or even chapter 2. Here, signal detection theory refers to the effects of non-sensory factors such as experiences, motives, and expectations on perception of stimuli. Accounts for response bias. This response bias should be related to the type 1 errors or type 2 errors that you make. And what else? Some of these concepts are really hard to stick. For example, the D prime being the signal strength and C is the strategy that is used. I'm like, what the hell? Because you need some sort of context on whatever you're studying in order to be able to differentiate them. Okay. Um let's just go with chapter 1, I believe. Since it's a lot of biology too, we can do it. So, chapter 1 for Psych-Soc is basically on biology and behavior. For the researchers, we have a bunch of good fellows from back in 18th century to the late 20th century. The last one being Sigmund Freud here. So it all started with Franz Gall, like modern psychology, I believe, is As much as I used to research about these like a couple of years ago, I think Franz Gall was an anatomist, and he was like the guy for phrenology. Now, what is phrenology? Let's see if we a detailed study of the shape and size of the cranium, so your skull basically, as a supposed indication of character and mental abilities. So this guy studied your head, skull, brain in hopes of trying to come up with ideas or hypotheses or theories about your mental abilities and your characteristics. Then comes Piers Florence, um, like about the same time, like couple decades later, and this guy, he was actually 40 years younger than Franz Gall, but he Pierre Florence just uh, demonstrated the functions of major sections of the brain. So he used extirpation to study parts of brain. Extirpate means rooting out and destroying completely. So he demolished the brain in order to study its parts. The use of every legal measure to extirpate the horrible evils evil from the land. Okay, then comes William James, who's actually famous, and he introduced functionalism. This is actually important. So, William James is the father of functionalism, which is how mental processes help individuals adapt to their environment. So, it's all about your function in the environment, in society, for example. And it is your mental processes, what's going on in your brain, that is enabling you to function as a member of the society. And then we have John Dewey. Tell me if which one is correct. He was the guy for functionalism again. So he also worked on functionalism, but after William James. Then we have Paul Broca, and if you know the Broca's region, the Broca's area, that's for speech patterns. So he studied people with lesions in specific regions of brain, and then that's why we have Broca's area, which is speech production, for speech production. We have Hermann von Helmholtz, and he studied the speed of impulse, made psychology a science. So this guy actually Helmholtz made psychology a science. Before that, it was not considered a science, surprisingly. And then we had Sir Charles Sherrington, who worked on synapses. And at the end, we have Sigmund Freud, who is the father of psychoanalytic perspective. So, now we have nervous system organization. For neurons, we have sensory afferent receptors. I'm going to go through this quickly as we have kind of covered this in the biology chapters in the nervous system. So these afferent sensory neurons have receptors that go to the spinal cord. Interneurons are between other neurons, mainly inside CNS, so spinal cord and brain. And the motor neurons are afferent inside CNS, and they attach to muscles and glands. We have reflex arcs that are interneurons in spinal, where interneurons in spinal cord relay information to the source of stimuli while simultaneously routing it to the brain. So these interneurons in the spinal cord send the information to the source of stimuli while simultaneously routing it to the brain. So it does also go to the brain. But since you have those interneurons in the middle too, they relay the information to the source of the stimuli. Central nervous system is brain and spinal cord. PNS is the nervous tissue and fibers outside of CNS. And we have somatic control, which is voluntary, and autonomic control, which is a sympathetic for fight or flight, or parasympathetic for rest or digest. Now we have influences of behavior, so let's get down to the chemicals, like neurotransmitters. These are released by neurons to carry a signal, and acetylcholine is a famous one. It is used by somatic nervous system to move muscles, also used by the parasympathetic and CNS. So somatic is the voluntary control part of our muscle movements, and also in parasympathetic and CNS it's used. Now dopamine maintains smooth movements and steady posture. We also know it as the reward neurotransmitter. We have endorphins and enkephalins. These are natural pain killers. Not natural killer cells. That was an immune system where these natural killer cells kill the cancerous cells. We have epinephrine and norepinephrine. They maintain wakefulness and mediate fight or flight responses. Epinephrine tends to act as a hormone, norepinephrine as a neurotransmitter. I did not know that. So epinephrine is a hormone where you like, but we do have epinephrine for the GPCR. You should see, what is that? Yes, it's a hormone, but it's not a steroid hormone. It's an amino acid hormone, a protein hormone, like amino acid hormone. Yeah. Now we have GABA, which is gamma aminobutyric acid. Gamma aminobutyric acid, GABA, short for GABA, and it is an inhibitory neurotransmitter, acts as brain stabilizers. Glycine serves a similar function. So we have glycine that acts like GABA. Glutamate acts as an excitatory neurotransmitter. I'm just gonna finish this chapter and then I need to go outside, and I'll be back in the evening so we can continue with that. Glutamate acts as an excitatory neurotransmitter. Serotonin modulates mood, sleep, eating, and dreaming. And the endocrine system is tied to the nervous system through the hypothalamus and the anterior pituitary, and a few other hormones. Cortisol is one of those hormones which ties the endocrine system to the nervous system. It is a stress hormone released by the adrenal cortex. It also raises your blood sugar by gluconeogenesis. Then we have testosterone and estrogen, which mediate libido, your sexual energy, like potential. your crave for sex, basically. Testosterone also increases aggressive behavior. Both are produced in gonads, released by adrenal cortex. Epinephrine and norepinephrine are released by adrenal medulla and cause physiological changes associated with the sympathetic nervous system. So from adrenal cortex we have cortisol and aldosterone, and from adrenal medulla we have epinephrine, norepinephrine, and these are for sympathetic nervous system. Cortisol is for stress. Our brain organization, we have it in the appendix, the full representation of the brain and its function for each region. The hindbrain is the cerebellum, medulla oblongata, and the reticular formation. The midbrain is the inferior and superior colliculi. Not to confuse this colliculi with the structures that were in the muscular system, which was canaliculi. Those were canals, but colliculi is colliculus. So different. We have forebrain, which is thalamus, hypothalamus, basal ganglia, limbic system, and cerebral cortex. And I did not know that, I had in my mind that cerebral cortex is the forebrain, but not the thalamus, hypothalamus, basal ganglia, limbic system. So the hindbrain, again, I'm just trying to review this for me. The hindbrain is your reticular formation, your brainstem, right? Which is medulla oblongata and cerebellum. And midbrain is just inferior and superior colliculi. And the forebrain is thalamus, hypothalamus, the limbic system, the cerebral cortex, and the limbic system, we said it, and basal ganglia. The methods of study are EEG, electroencephalography, regional cerebral blood flow. You measure the regional cerebral blood flow. So you do measure blood flow in the cerebral regions with EEG. Then we have forebrain. Okay, now thalamus is the relay station for sensory information, right? So sensory info, relaying it is by thalamus. Then we have hypothalamus. This is the 4 F's: fornicating, food, fight or flight. So hypothalamus, the homeostasis, for balancing everything, bringing our body to equilibrium. And the 4 F's, it integrates with endocrine system, hypothalamus to hypophyseal portal, and then the anterior pituitary. And we have basal ganglia, which smooths movements and helps postural stability, kind of like dopamine. Is dopamine related to basal ganglia? Limbic system has septal nuclei, amygdala, and hippocampus. So septal nuclei is for pleasure and addiction. Dopamine should be related to this too. Amygdala for fear and aggression, and hippocampus for emotion and memory. We know hippocampus is for memory, but emotion too. And specific types of emotion, which is fear and aggression, is with amygdala. Now, septal nuclei, I have never, it has never appeared to me, but it's for pleasure and addiction. The four lower lobes for the cerebral cortex is the frontal, which is for executive function, impulse control, speech, and motor. These are advanced, and it's the most advanced part of our brain, the frontal cortex. And then we have the parietal, which is for touch, pressure, temperature, pain, and spatial processing. And occipital is for visual, back of our brain. And temporal is for sound, speech, perception, memory, and emotion. And so emotion is not with parietal, and touch, pressure, temperature, pain, spatial processing is not with temporal, it's with parietal. It's on the top of your brain. On the sides, it's mainly close to ear, which is for our sound, speech, and what you hear, and what you instill in your memory. So it's related to memory. And no other ones is for emotion, because frontal lobe is actually emotion control, so it's impulse control. And the perception of speech is from your temporal lobe, but the speech production comes from your frontal lobe, I believe. But still, we'll go to the Broca's region in Wernicke's area, so let's hang on for a second. Now we have cerebral hemispheres. So the left is analytic, language, logic, math. So if the left hemisphere is for the mathematical stuff, it means that you're right-handed, right? But the left-handed people are very artistic, so usually dominant right. So dominant right is more usual actually, and it's for intuition, creativity, and spatial processing. Then we have the development. So the nervous system develops through neurulation, in which the notochord stimulates overlying ectoderm to fold over, creating a neural tube topped with neural crest cells. So the nervous system develops through neurulation. This is what we call the development of the nervous system. The notochord, the cord, stimulates overlying ectoderm. So ecto is, so meso is for movement, like muscular system, skeletal system. It's not for nervous system. The endo and ectoderm. So endo is whatever is inside, like the digestive tract, stuff like that. And ecto is nervous system and anything that's outside of our body. So ectoderm to fold over, creating a neural tube. So again, the notochord stimulates the ectoderm to fold over and creates a neural tube, which is topped with neural crest cells. So on top of the neural tube you have neural crest cells, and it was the notochord that stimulated the overlying ectoderm. Neural tube becomes the CNS. So tube, the CNS. What becomes the PNS? The crest cells spread out throughout the body, differentiating into many different tissues. So crest, penis has a crest. We have primitive reflexes. These exist in infants and should disappear with age. First one is the rooting reflex, turns head towards stimulus. So you root for something, you turn your head towards it. Head for rooting. Moro reflex, think extending arm, responding to falling sensation. So falling is with more. You extend arms. And Babinski is for the foot. The big toe is extended and the other toes fan out in response to brushing on sole of foot. This one we know it. And grasping reflex. Grab anything that we put into your hands. There should be other names for these, and we want to make sure that we know the other names for it as well, as this document might not be complete. Then we have developmental milestones, gross and fine motor abilities progress head to toe and core to periphery. So head to toe and core to periphery. So it's first core, it's first head, and then to your toes, and then to your peripheries. And social skills shift from parent oriented to other oriented. And language skills become increasingly complex. So for language, social, gross and fine. Motor skills. Nice. Okay, so we're done with this chapter 2, and I'll see you. So I'll just note here that we did chapter 1. Took me 2 days, 2.5 days to do this, and still I did the cars patches last night, and did also review stuff. So officially we have done our first set of exercise, just to give me some motivation to get back on the roll. And I'll see you very soon, so we can continue with the next chapters and do more questions, and just let's get it on, man. Let's finish this, and let's succeed all together through this exam. It's a good test. I like it. It's very, very challenging in terms of the knowledge base, the variety of facts, information that you need, the principal, fundamental knowledge that you're learning. So, for now, peace.